So basically we are studying motion in a straight line. Motion in a straight line means a car moves in a straight path and doesn't change lanes, moves in the same lane. So it may change direction but doesn't change lanes. So it's like this. Suppose a car, this is a straight line motion. This. Now direction may change, it may come back. It may come back. That is also motion in a straight line. But if it does like this, then it is no longer motion in a straight line. We will not deal with that. We will deal with only motion in a straight line for the time being. Okay. So what is uniform motion? Uniform motion means the speed meter gives the same reading all the time. Suppose you are driving a car, if you are looking at the speed meter, it reads always 60 km/h. It doesn't change with time. So that is example of uniform motion. And if the speed meter changes, then it is non-uniform motion. So define uniform motion in the following way: particle traverses equal distances in equal time intervals. Okay. Next is speed. What is the speed? Speed is defined as distance traveled by time. Speed is distance by time, right? Average speed is distance by time interval. It is also distance by time. Now the speed may vary. Say a car moves along, say a car moves like this, see fast. Now a small part of the lane, it moves with a certain speed, and then a large speed, and then small speed again. So if you calculate the speed at various intervals of time, the speed may vary. Okay. So that means from moving from here to here, if it moves slowly, the speed is less. If it moves fast, in this interval the speed is more, and again the speed is less. So during this total interval of time, the distance by speed is average value of the speed, V average, right? Now this speed is denoted by V, right? Now one example I will show you by a certain problem. I will show you an example. Say a particle covers, say a particle moves 10 meter in 5 seconds, and the next 10 meters in 10 seconds, right? Now what is the speed? What is the speed in the interval of the first 5 seconds, then the next 10 seconds, that is a question. And also one more question is that what is the average speed of particle during the journey, during the whole motion. So as you see here, particle moves first 10 meter in, so this is first 10 meter in 5 seconds. So in the first 5 seconds, the speed is equal to 10 by 5, that is 2 meter per second. Now in the next 10-second interval, the speed happens to be equal to the distance by time 10 seconds, that is 1 meter per second. So the speed during the journey is not constant. So this is an example of non-uniform motion. The whole motion is non-uniform motion, and during the whole motion, during the journey, that means the whole journey is of 20 meter, the average speed is equal to the total distance by total time. So what is the total distance? 10 plus 10 divided by total time is 10 plus 5, 15. So that's 20 by 15 meter per second, that is equal to 4 by 3 meter per second. So this is the average speed of the particle. By the way, so next, the velocity. What is meant by velocity? You know, speed. By speed we mean a scalar quantity. That means a speed, only the magnitude of the speed, say 60 kilometer per hour, say 5 meter per second, that information is sufficient. Now velocity is a vector quantity. Velocity is a vector quantity, and that means it has magnitude and direction both. Magnitude and direction both. So basically you can think of velocity as a speed with direction, right? So it's a speed with direction. Now for our one dimensional motion or motion in a straight line, it will change signs. Suppose if you consider this direction as positive, if this is positive direction, now if the particle moves here this way with a velocity 10 meter per second, so that's v1. Velocity is also denoted by v. Okay. Now if this particle moves with a velocity v2, suppose this is 10 meter per second also. So as velocity is a vector quantity and this is our chosen direction, if you write the quantities with sign, then you have to choose a direction. So this is our chosen positive direction. According to this direction, what is the value of v1? Here from the diagram, v1 is plus 10 meter per second, and v2, as it is this way, so minus 10 meter per second. As these v1 and v2 are velocities, that is why we write it with signs plus and minus, depends on the direction. And direction, remember, it is up to your choice which one you will consider as positive and which one direction will consider as negative. Average velocity is in a next page we will write. Average velocity is equal to displacement by time, or the time interval in which the displacement occurs. Okay. Suppose one example we will consider. Suppose a particle moves 10 meter towards right in 2 seconds and moves 5 meter backwards, that is to the left, moves the next 5 meter, right, next 5 meter just after going this 10 meter in the next 2 seconds, in the next 2 seconds, right. So find during the interval, during the total interval of 4 seconds, 2 plus 2 4 seconds, it's average speed, average speed and average velocity. Okay, so these are, it is the diagram. Now we'll choose a direction. We are working with vector quantity here, velocity, so this is the positive direction. This is very very important in solving problems. Positive direction, that is the right. I am choosing the right direction as positive. Okay, so it moves, say this is a starting point, start, so it moves 10 meter, right? So this distance is 10 meter, moves 10 meter in 2 seconds, and from here it comes back 5 meter, so that's 5 meter. So this is the final position and this is the intermediate position. Okay, so what is the total distance traveled? What is the total distance traveled? So in the interval, in the 4-second interval, distance traveled is how much? Distance traveled, this 10 plus 5, 15 meter. Okay, now what is the displacement? Displacement, what is that? It is the initial position to final position, the line joining. Displacement is the line joining the initial position, this one, to the final position. So that's the displacement, right, this way. So displacement is, see here that this whole thing is 10 minus 5, so that's 5 meter. So displacement is equal to 5 meter. Okay, so average velocity or average speed, first one, average speed equal to distance by time. So 15 by 4 makes it how much? Whatever. So it's 15, we can keep it in fraction also. It's 15 by 4 meter per second, and average velocity is equal to 5 by 4 meter per second. So this is the difference between velocity and speed. Suppose in another example, say this is a particle, suppose this is a car, that's a car, it goes like this, takes a sharp turn. So this is 10 meter distance, and that is also 10 meter. Okay, say this point A to point B. So car moves from A to B in 2 seconds. Find its average speed and average velocity. So you'll work it out here only. Average speed will be total distance how much? 20 meter by total time 2 seconds, that's 10 meter per second, and average velocity is equal to, right, what is the displacement? See, this is a right angle 90 degrees, so this, so displacement is this, the line joining A to B, that is the displacement. How much it is? See, it becomes a right angle triangle, 10 10, and this is the hypotenuse 10 root 2. So 10 root 2 by 2, right? So that's 5 root 2 meter per second. Okay. Now next comes acceleration. Acceleration. See, acceleration is denoted by a, that is change in velocity, change in velocity divided by the time taken for the change. So suppose, say if suppose u is the initial velocity, and v is final velocity, and suppose t is the time interval, then the acceleration is v minus u, see the change in velocity divided by the time interval. So therefore we can take it to that side, v equal to u plus at. Now these are all vector quantities, remember. So we are dealing with one dimensional motion in a straight line. So these all will come with signs, right? So let's try one or two examples. Say this one. Say a car changes velocity from 10 meter per second to 20 meter per second in interval of 5 seconds. Find its acceleration. So it doesn't change direction, that is at there it is, u is equal to 10 and final velocity is equal to 20 and time is equal to 5 seconds. So therefore a equal to v minus u by t, that's 20 minus 10 by 5, that is 2 meter per second square. So the unit of acceleration is this 2 meter per second square, because it's the unit of acceleration SI unit, it's meter per second for velocity divided by second. So that is equivalent to meter per second square. Now suppose in an example like this, suppose a particle moves towards right at 10 meter per second, and in say after 2 seconds its velocity changes to say 10 or say 20 meter per second towards the left. Find its acceleration. Okay. So before solving any problem, what is the rule? To choose the direction. So that is the positive direction towards the right, because these velocity and acceleration, these are all vector quantities, they come with magnitude and direction both. Okay, so towards right. So that's 10 here, and after some time, doesn't matter where it is, so that's 20 meter per second. So u equal to plus 10 meter per second and v equal to minus 20 meter per second, and t equal to 2 second. So therefore a equal to v minus u by t, that is minus 20 minus 10 by 2, that is this happens to be minus 15 meter per second square. So the acceleration in this problem comes out to be negative. So what is the meaning of negative acceleration? That is there. This is the acceleration of 15 meter per second. Its magnitude is 15 meter per second square, but direction towards the left. This negative sign shows that direction is towards the left, because right is our chosen positive direction. What is the meaning of this leftward acceleration? That means if you look at the situation, then you know Newton's law says that according to Newton's law, force F equal to ma. So that's force, that's mass, and that is acceleration. Now force is a pull or push. So if there is a block and say you are pulling the block, you pull the block there, right? So you are applying force on the block in which direction? This way. Force, this is the direction of force, this is a pull. Or you can also push the block, see, or like this, say. You can also push the block. If you push the block, the force will be this way. Okay. So in this case, this is the direction of acceleration of the block, and in this case, this is the direction of acceleration of the block. And in that problem, the particle's velocity changes from 10 meter per second to 20 meter per second in this way, and see, this was our chosen positive direction, and the acceleration was here in this direction. It was 15 meter per second square. That means the direction of force in that problem is which way? The direction of force is this way. Right? So this happens in motion under gravity. See, if say for this problem, see, if you just tilt this paper this way, velocity towards the right will become upwards. Or suppose we give a new problem here, say a particle is thrown with a velocity 20 meter per second, right? So after some time, what will happen? Direction will reverse, and suppose you take this direction as positive direction, upward direction, positive. So what will you get? So for the x, so that's u and this is v. So the acceleration calculated here, so the acceleration calculated will be negative. Obviously it will be negative, because according to our chosen direction, the acceleration will be negative. Even if velocity decreases in the same direction also, the calculation for a will be negative. So a is less than 0. A is negative. What does that mean? The direction of a is, that is the positive direction, so that's a. This is the direction of acceleration, and we can conclude this is the direction of force. And obviously this is the case of motion under gravity. Motion under gravity. So in motion under gravity, the acceleration will have a constant value. So motion under gravity motion under gravity, all bodies have same acceleration that is known as acceleration due to gravity. Denoted by G. And value of G is equal to 9.8 meter per second square. Often we approximate it as useful for problem solving. In our case, most of the cases we will approximate it to be 10 meter per second, right? So suppose this motion under gravity, so suppose a stone is thrown at a velocity of 20 meter per second. So for example, a stone thrown up at 20 meter per second, this is the initial velocity, vertically, obviously thrown up at 20 meter per second vertically, will have velocity how much after 2 seconds? Fill in the blanks. How much velocity it will attain after 2 seconds? So for solving this problem and all problems of this type, our first job is to consider a positive direction. So we'll choose this as positive. That means this vertically upwards, positive direction, and u is equal to, it's thrown upwards, so plus 20 meter per second, and the acceleration is how much? See, the acceleration is always g downward, right? Acceleration, g is a magnitude, g doesn't have sign, so g is 10, so the acceleration is 10 meter per second square, right? G is 10, g doesn't come with sign. Now this a, how much is a then? When as my chosen direction is positive upward and the acceleration is 10 meter per second square downwards, so it's minus 10 meter per second square. Okay, so we have to find velocity after 2 seconds. So we'll put the values u equal to 20, a equal to -10, and t equal to 2. Let's put in the equation v equal to u plus at. Therefore v equal to u plus -10 into 2, so that's 0. So what is the meaning of velocity 0? That means after 2 seconds the body will come to rest momentarily, right? Now say if we calculate velocity at, so suppose what will, for the same problem, what will be its velocity after 1 second, and one more, what will be its velocity after 1.5 second. Let's see. So here also that same positive direction upwards, u equal to 20, right? It was 20, na? U is 20, yeah. And this is the acceleration due to gravity, always downwards, always, as this is our chosen direction. So there we are starting the problem, right? So there our chosen direction is upward and acceleration due to gravity is downward, 10 meter per second square. So a is -10. Okay, so we'll use v equal to u plus at. Okay, so v at t equal to 1, v equal to 20 minus 10 into 1, that's 10 meter per second. That is, at t equal to 1 it is still moving up at a velocity 10 meter per second, right? Now at t equal to, okay, 1.5 will not do, we'll do at 3 second, right? We'll calculate at 3 second, because already at 2 second it was at the topmost point. Momentary rest means the topmost point. Okay, so at t equal to 3 second, velocity equal to, see, u plus at, u 20 minus 10 into 3, that's minus 10 meter per second. That means at t equal to 3 second, this particle was moving downwards with a velocity of 10 meter per second. So it's like this. So thrown here. So suppose the starting phase, the initial condition means here the time is 0, right? Time is 0. T is variable. So time is 0. Then it was thrown up at 20 meter per second. I mean the stopwatch is 0. Stopwatch is set to 0. Now when the stopwatch is t equal to 1, it's going up at 10 meter per second. Now when the stopwatch is t equal to 2, then it stops momentarily, and then again it comes back, and this is obviously t equal to 3, it's 10 meter per second downward. Okay. And at t equal to 4, obviously it will be here. Let's try out. At t equal to 4, at t equal to 4 second, v equal to u plus at, that is v equal to 20 minus 10 into 4, that's minus 20 meter per second. So after 4 second it reaches ground again, that means it is thrown from ground, so it reaches ground again. So we can have a general formula of this, that suppose that's ground is thrown up with a speed u, and obviously this a is equal to minus g, right? Okay, why minus? Obviously because of my chosen direction. The chosen direction is upward, positive. So you can write if a particle is thrown up at speed u from ground, then it reaches the topmost point after time u by g, and its total time of flight is twice u by g. Simple. That is what we had done in the last problem. So there just here to put v equal to u plus at, put a equal to minus g, and that u is same as u. So therefore at topmost point v equal to 0, so put 0 equal to u minus gt. Okay, so t equal to u by g, so u by g, so at t equal to u by g, it reaches highest point. Okay, so if it's thrown, it will reach the highest point, and for a moment it will come to rest, and then it will come back again. So how do you prove this? Total time of flight 2u by g. Well, you can make a guess that the time to go up is equal to the time to come down, or if you don't want to make a guess, you can put it up like this. See, we know the equations of velocity only, so that's u, and at least this guess you can make that when it comes back, it comes with the same speed but downward. So here you put v equal to minus u, right? So put final velocity v equal to minus u, so it's u but in the reverse direction, comes back with the same speed. As it comes back with same speed, okay, so v equal to u plus at, put a equal to minus g, v equal to minus u equal to u minus gt, therefore t equal to 2u by g. So that is the total time of flight.